Okay, so question 5. So prove by induction the formula for the sum of the first n terms of a geometric series. That is, prove that for or not equal to 1. Okay, so we go through our steps. So our basic step is where we prove that the statement is true for n equal to 1. It does say all natural numbers, so n equal to 1 is the first or most basic step. So n equal to 1 on the left hand side is a, and take the right hand side and let n equal to 1. So or to the power of 1 is just or, and then they cancel and you get a. So the left hand side equals the right hand side. Basic step. Next one is the assumption step. So this is where we assume it true for n equal to k. So we assume it's true for n equal to k. So a plus a or plus a or squared, a or to the k minus 1 equals a times 1 minus or to the k over 1 minus or. And then the inductive step. Is where we prove that it's true for n equal to k plus 1 given that n equal to k is true. Okay, so that is a plus a or squared plus dot 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 plus a or to the k, to the k minus 1 plus a or, and now we replace k with k plus 1, so it's k plus 1 minus 1. Yeah, so I replaced that with that, and the minus 1 just stayed. Okay, and then same on the far side, so a times 1 minus or to the k plus 1 over 1 minus or. So we manipulate the left hand side using the assumption and make it equal the right hand side. So this bit here is this. So it becomes a times 1 minus or to the k over 1 minus or plus a or, and that's just to the k now because the plus 1 minus 1 cancels. And we need to make this equal this. So I think a common denominator. So make that, and the common denominator will be 1 minus or. So for the fraction on the left, we're not changing the denominator, so we won't change the top line. Now the fraction on the right, though, we are multiplying the denominator by 1 minus or, so we need to do the same thing on top. So it's a or to the k, and we're going to multiply by 1 minus or. Yeah? I don't really know, so I'm going to multiply it out, so like distributively, like this way, and see what I have. So a by 1 is a by or to the k is just a or to the k. Plus a or to the k, then going into the second bracket. Oh no, what do we do with this? I don't know, so I'm just not going to do it. So plus by minus is a minus, and then it's a or to the k times or. It's the a that's throwing me. Anyway, I'll figure it out now. They cancel, which is nice. So sorry, I don't think I need it because I'm just going to take it out, but I'm just going to talk to you about this bit for a second. So I'm not really sure what to do with this if I had to continue with it because of the A. So it's just a nice problem solving technique if you can put numbers in and then see if it makes sense. Do you know what I mean? So if I had like 2 by, I don't know, 3 to the power of x by 3, or even actually if I make this a power, so it's 3 to the power of 4 by 3. So yeah, it does make sense. I could do 2 by 3 to the power of 5. So I can combine the two ors. Yeah. Okay. Anyway, that's just a really nice problem solving technique if you can't figure it out because it's all in variables and it's really confusing. If you just use appropriate numbers and then kind of process it, and you can kind of tell if the maths you're doing is legitimate. So I could turn this into a times, and the power on that or there is a 1. And just like I did here, I had a 4 and a 1. And the 4 and the 1 made 5. I added them. I can add these. So it's or to the k plus 1 over 1 minus or. I'm going to take the a out on the top line, which leaves me with 1 minus or to the k plus 1 over 1 minus or. And I think that's what I was looking for. Yep. So that equals the right hand side. So therefore, the statement is true for n equal to 1. It has been proven true for n equal to k plus 1 given n equal to k is true. This implies that it is true for all n where n is natural numbers. That's your little spiel at the end. So that is worth, where's my induction? Here, 10. So 10 marks for that one. And then we go down here. So it's a surd equation from algebra. If you have a surd equation, you basically need the surds to be on different sides. You can't do it when they're on the same side. So we're going to minus the square root of x minus 1, and we're going to minus the square root of x minus 1. So I have the square root of 2x minus 1 equals 5 minus the square root of x minus 1. And I'm going to square both sides. So squaring the left, because it is just a square root squared, they just cancel, so I just have 2x minus 1. The right is a little bit more complicated because essentially this is what I'm doing. Yeah, I'm squaring it, so it's like a first term, second bracket. So it is 25 minus 5 root x minus 1 minus 5 root x minus 1 plus, and it's going to be the square root of x minus 1 squared. So 2x minus 1 equals 25 minus 10 root x minus 1s. And then this, the square and the square root cancels, so it's just plus x minus 1. I'm going to move all this across. So I'm going to move minus 25 over. I'm going to move the plus x, so that's a minus x. And I'm going to move the plus 1. Sorry, the minus 1, so it's plus 1. That's gone, that's gone, that's gone. So, just tidy up this little mess over here. So 2x minus x is just x. And minus 25 minus 1 plus 1 is just minus 25. And that equals minus 10 square root x minus 1. So, as always happens when you've got 2, you have to square again. So this one is x squared minus 25x minus 25x plus, plus 25 squared, 625. And on the other side, we square the minus 10, so we get 100, and we square the square root, which is just x minus 1. So the square roots are gone. So x squared minus 50x plus 625 equals 100x minus 100. And then bring that across. So it's x squared minus 150x plus 725. Yeah? So I minused the 100x and I minused the 100x. And I plussed the 100 and I plussed the 100. And that's where that came from. Can I get factors of... oh God, no. Oh, 5 and 45, would you believe? So the guide number is 725, but if you multiply 5 by 145, is that right? 5 by 145? Yeah, you get that. I want it to be minus 150, so I need double minuses there to get that. Put it back in, so x squared minus 5x minus 145x plus 725. You've got your first bracket and you've got your second bracket. So the common factor in the first bracket is x, leaving x minus 5. We're definitely going to take out, we're going to take out a minus. 5 left. So does it, oh yeah, it must. Sorry. Yeah, so I can take out 145. So I took the minus away, which means that's a plus x. This becomes a minus and it's 5. Sorry. Yeah. Write down the matching brackets, which is x minus 5, and then the highest common factors, and then let each bracket equal 0. So plus 5 plus 5 plus 145 plus 145. So x is 5 and x is 145. Oh, sorry, it's way behind. Okay, so I'm just going to make sure. Oh, verify your answers. So I have to sub back in. Verify your answers means sub back in. So let's see. I'm just going to write this and then I'll bring it to the same place as me. Root x minus 1 equals 5, and we've got x equals 5, and we've got x equals 145. Okay, so I'm over here verifying. So we'll do the 5 first. So 2 times 5 minus 1 under that square root plus 5 minus 1 under that square root, and that is supposed to equal 5. So what's that? 10 minus 1, so that's the square root of 9, which is 3. This is the square root of 4, which is 2. So that works. So x equal to 5 is definitely a solution. The other one is 2 times 145 minus 1 plus the square root of 145 minus 1. And again, that is supposed to equal 5. So 2 times 145 minus 1 is 289, and the square root of 289 is 17. And then 145 minus 1 is 144. Square root of 144 is 12. So that doesn't work. That's 29 equals 5. So that one doesn't work. Yeah, so 145 is not a solution, 5 is a solution. 15 marks. So that is 15. And I think that's that question. It is. So that is 15 and 10 is 25 for question 5. Yep. So 25 for question 5.